Today we will talk about a case study involving the US election in 2004, where Bush narrowly won against Kerry, and the election in the entire United States just hinged on the results in Florida. And in Florida, Bush won by 350,000 votes out of 21 million people at the time, so 1.6%, so a fairly narrow margin. Now, there was a researcher somewhere on the West Coast, and his name was Hout, and he examined a data set of election outcomes with one observation for each of the 67 counties that Florida has. So there are 67 observations in total in the data set. And as things go, the result was sensational or interesting and was picked up by the popular press. So there was a headline, Florida votes Fishy, in Wired online here. That link is no longer active. They discovered that in 15 counties using touchscreen voting systems, the number of votes granted to Bush exceeded the number of votes Bush should have received, given all the other variables, while the number of votes that Bush received in counties using other types of voting equipment lined up perfectly with the variables would have predicted for those counties. I should add that e-voting, using these touchscreen machines for voting, was new at the time, and people were worried about fraud. 15 counties of the 67 were using this new technology. Okay, so let's see. What does this mean? It means, the article implies, that there was an indicator variable for e-vote in the model, which was turned on for the 15 out of the 67 counties. And the e-voting was associated with more votes, so there should be a positive coefficient, and it also implies it was significant, because otherwise you shouldn't make a statement like this. Okay, so the next slide shows the Hout model on which this statement is based. By that I mean the x variables. It was linear regression with x variables. We have the percentage of people who voted for Bush in 2000. The current model is about 2004, right? But what election results in 2000, also for Bush, because Bush was a two-term president, bear, of course, relevance here. Then Hout added a squared term here, so the whole thing squared. Then from 1996, he had the percentage that Dole got. Dole was, I don't even remember whether he was Democrat or Republican. So, and then votes in 2004 were the total number of votes cast in 2004, the year of interest, the indicator for e-voting. Hispanic is the percentage of Hispanics in this county, our county level data set. Income, median income in the county. Then the votes changed, the voter turnout change from 2000 to 2004. And then two interactions where we are interacting the indicator variable e-vote, yes or no, with the Bush percent vote and the squared. So we even have a squared variable interacting. All right. So the Hout model in its entirety is here. We see R squared is 53%. This is a social science data set. 53% is pretty good, right? We never get 90% or even 80%. So 53% is pretty good. So e-voting here has a positive coefficient, and more importantly, it's significant. So it's exactly what Hout said. Okay, so we're now backing up, and we're gonna go as if we didn't know this. And if we didn't know this, we would run a linear model at the beginning without interactions and without quadratic effects, just to get started. And if we do that, so this is the same regression, except those interactions and quadratic effect removed, we are getting a slightly negative coefficient for e-vote, but it doesn't matter because it's not significant. right? So no effect of e-voting. And it's not a little bit not significant. We're talking 86%, like it's not significant. All right. Diagnostic plots. Do we meet our assumptions? Normality, check. Studentized residuals. We have 1, 2 greater than 2, nothing greater than 3, nothing greater than 3. Here maybe 1, 2, 3, that's 5. Yeah, I can't quite tell. So about 5 out of the 67 observations are greater than 2. Nothing too unusual. So residuals versus predicted values. Well, so we're looking for constant variance. You could make up a story here a little bit, but it doesn't hit you over the head. So I'd say more or less constant. There's no evidence against constant variance. All right, so leverage and leverage against something. Here we plotted against standardized residuals. And so we see also that have leverage and large residuals. We have some negative residuals here at -2, of course, corresponding to those over there. These are standardized, those were studentized. But then we have 2 large leverage observations. In particular, Martin County has quite a bit of leverage. Now, leverage means it's unusual in X, right? It has nothing to do with Y. When we have a high leverage observation, then we look at why is it high leverage. So here is a parallel coordinate plot. In a typical scatter plot, we have 2 axes, and the 2 axes are orthogonal to each other. Here we have more than 2 axes, and they are parallel to each other. So we have 1 axis for e-voting with the values 0 and 1, the smallest and the largest value. Then we have the percentage of people who voted for Bush with the smallest value and the largest value and intermediate values, and so forth, percentage Hispanic, and so forth. So you can see you can get more values over here. Each line, more variables. Each line corresponds to 1 county, and the red line is Martin County. Yes, Martin County. So where is Martin County unusual? Here. It has by far the largest percentage of Hispanic votes, and also the largest number of votes in general. Here the 4 is cut off to 2004. Not by a lot, but still the largest. And so the combination of this and that, especially this, probably drives that high leverage value. Okie dokie. Okay, so what should we do? It's actually true. It's not a data entry error, right? So Martin County really does have many Hispanics. Now, if we had found that e-voting was significant, what I'd do is I'd remove Martin County and see whether then suddenly it's not significant, because we don't want to reach a conclusion that is really based on only 1 observation. But it's not significant, and it's not a data entry error, so there's no reason why we need to take action here. Given that the Hout model has a quadratic effect, we could also look for a quadratic effect here. And so this is our 5th diagnostic, or maybe it was the 2nd in the order we presented. So we're looking at the residuals as a function of the X variable of interest, where we might suspect a quadratic effect. What do we see here? Nothing. Definitely not a quadratic effect. So there's no reason to add a quadratic effect. Now, if we did add a quadratic effect anyways, because of the Hout model, now if we did add it, the quadratic effect is not significant, and the e-voting is not significant, and so there's really no reason, because the quadratic effect doesn't do anything. Okay, now we have to back up, but this is the end of the current section.